Pact session. Before we really begin today, I would like to tell you how and why I started researching this topic I'm going to tell you about today, and why I even started to think about having confidence when it comes to deploying code changes to production. So 4 years ago, I was hired as a consultant for a company, and I was put to work on an application that our clients had. So you can picture it like this, just one big box with everything inside. Everything was tightly connected, and it was very, very stable. And one of the reasons why it was so stable was because it had been developed with a mindset of a tester. So when you write code, you should also have tests covering that part of the code, covering your contribution. So every time that I made any code changes, I could run this whole suite of tests, which gave me the assurance that I had not broken any of the internal functionality in the application. And the existing test suite contained of hundreds, if not thousands, of unit tests and integration tests between the different components. And we had dozens and dozens of end-to-end tests covering every feature of functionality that we provided. And finally, we had 1 or 2 dedicated testers that performed manual testing and wrote automatic tests using third-party applications. So we had very good test coverage, to say the least. But there was a problem, because at this point, we were also starting to provide an increasing amount of external REST APIs to let other organizations use the services that we provided. And I could never be certain that I didn't break any of the functionality that these external applications was depending on, even though I could be sure that the application itself was working fine. But all in all, it was a very safe project because we had months, years of test work that safeguarded us from doing anything wrong. And as a junior developer straight out of the university, I must say it was kind of nice to have it that way. But the next year, my boss came to me and told me that I was going to be a part of a new project. So I was going to be a part of a small team that was given the task of rebuilding this monolithic application into smaller and more manageable services. So instead of having this, we were going to have something like this. Or we can zoom out even more, actually more like this. This is roughly how it looks like today. And while we were chipping away at that old monolith, we realized that we could not really port all the tests. In fact, we realized that almost all of the existing tests were impossible to port. So I was now suddenly left without any certainty that the changes that I would make to one application would not have dire consequences to the whole system. We could not really port these tests because that was done by just importing different components into one class and performing a test that way. And the same with the end-to-end tests. It was the same. We just imported all the different components into one Java file and wrote the test for that. So I started to wonder, how can I confidently deploy a new version of my service? So let's investigate a little further, and let me try and define what the problem really is. So this here is now an example illustration of a microservice architecture with just a handful of services. So each square represents a service, and all the lines are possible communication between them, meaning that one service may use APIs served by another. And this here is the problem. Because in a microservice architecture, we have an unknown number of smaller services working together as a connected system. And in this type of architecture, it makes each individual service easy to build and deploy. But these services may or may not communicate with each other. And there is no good way of knowing or of making sure that any of the changes that you make to one application does not change the behavior of any of the other applications. And there's actually no good way of knowing if these services are communicating with each other or not. application A could, for all we know in this illustration here, serve APIs to all 5 of the connected services or none. We have no good way of discovering these dependencies in the system. And if we take a closer look at this illustration, we can also see that we don't need many services before an illustration like this becomes very complex and hard to understand. And microservice systems can be composed of a handful of services like this, or it can be, in extreme cases, 1,000 services like it is at Netflix or Uber. So how could I ever, as a developer, be confident that I won't break any of these connected services if I have 1,000 interconnected services in a system? So the real question here is, how do we avoid dependencies in a system? And the answer to that is fairly simple. It is API versioning. So API versioning is a great tool to decouple dependent microservices, and I hope that you all use that if you have a connected system or microservice architecture today. Because supporting multiple versions of an API makes further development possible by removing all the limitations that you get from having existing users of your API. Unfortunately, we also run the risk of having to develop and maintain a limitless amount of API versions unless we know when we need to create a new one and when we can remove one of the older ones. So this next illustration, it shows us the relationship between an API provider and a consumer. So when a provider service creates and documents an API, they are really creating a contract to that consumer that wants to use their API. And this contract states, this is how you, as a consumer, can and should use the services that I am offering. And when the provider wants to apply some changes to their service, it is their responsibility to make sure that any changes to that API will not break any of the consumers. The provider needs to make sure that they do not breach their own contract. So to decouple the provider from the consumer, we need to use API versioning. So when a breaking change occurs at the provider, developers will need to create a new version of the API. But how do we know if we have a breaking change? So the first solution that came to mind, which is a bad one, is that I could start an instance of my application, and then I could run all the integration tests from all the other applications to mine to make sure that it's okay. But that is depending on me knowing how to find, download, and start every consumer that uses the services that I am offering. And I bet that most of you do not have a proper way of knowing each and every application that is using services between each other. So we need to find a better way of discovering these breaches in existing API contracts. And a possible solution to that is to use the topic of today, consumer-driven contracts. So consumer-driven contracts is a testing paradigm where providers of an API encourages consumers to write integration tests for them. And in return, the consumer can be certain that the provider will not make any unwanted changes to the part of the API that the consumer is using. And a consumer-driven contract test is exactly like an integration test, but instead of being runnable on the consumer side, it's runnable on the provider side of the equation. And I will show you how this works in a code demo later. So this illustration has so far described the relationship between a provider and a consumer as unidirectional from the provider to the consumer. But to have a healthy relationship between two applications, we need to expand it to also include consumer-driven contracts. And when the consumer writes a consumer contract, they are essentially telling the provider that this is how I am using your API. So the provider will now have access to information about which consumer is using their application, which endpoints or which parts of the API they're using, and how they're using it. And this is essential information if essential information needed to be able to reduce the number of API versions that you want to provide. So we need to know who is using your API, what part of the API are they using, and how are they using them. And with consumer-driven contracts, all of these questions will be answered. But how can we do consumer-driven contracts in practice? Well, we can do it by using a framework called Pact. So Pact is a framework for implementing consumer-driven contracts into your applications. And it's this framework I have been using for the demo, so this is what I'm going to show you. So Pact makes it very easy for consumers to write consumer contracts, or pacts as they call them for short. And it does so because it has multi-language support for creating pacts. This means that you can write your pacts with the same programming language that you're already using in your application. Pact support languages like .NET, Java, Scala, Kotlin, Ruby, Swift, JavaScript, Go, and more. I haven't checked the status of that in the last 6 months. So it's very versatile. Pact is also language independent during the verification process. And this is great because it makes consumers who like to write applications in .NET, they can write their tests in .NET even though the provider is written in Java. So it's language agnostic. And it's easy to share pacts between consumers and providers because Pact has created something called a Pact broker, which is an application that consumers will upload their pacts to and where providers can download them whenever they need to verify a pact. So this is just a screenshot from the Pact broker. We will see more of the Pact broker later, but I just want to show you a preview. And the Pact broker, it displays pacts in a human readable form. So normally it's a JSON structure, but this is easier to read. So we need to talk about the difference between a contract test versus an integration test. So contract test and integration test, they are very similar, but as I said, one is runnable from the consumer side. So integration test, you run them from the consumer. And a contract test is runnable from the provider side. You run it from the provider code base. And what this does is that we can escape what I like to call integration test hell. And integration test hell is a combination of some inherent problems with integration tests. So integration tests, they are hard to run because they are dependent on having an existing environment to run in. So, or you could download every application to your local computer and start every database and instance in your system locally and try and run your integration tests. And integration tests, they might fail for unknown reasons. It could be network issues. I don't know. But it's not unheard of that integration tests will fail even though they should have passed. And these two problems together, they create a third problem, which is that developers are lazy. So they will ignore unreliable tests. At least that was what I do. So normally, an integration test should be an actual call from your application to the other application that you want to test. So a real request will be sent, and when the provider application responds, you do some validation. But nowadays, this is often converted to something like this, where instead of using an actual call or real client, we're using mocks and stubs. And this does not really make sense. Because in this scenario, the integration test will not actually achieve anything, as we're just using a dummy client and a dummy response. So integration tests using mocks and stubs will in fact become stale the minute that you complete writing it. Because the mock response that your test responds with is just a snapshot of how the provider application used to work one time in the past. But this illustration is actually a good representation of what a contract test looks like on the consumer side. The consumer will provide the request that they would like to send and the expectations they have for the response. And the consumer application will only work on dummy data because the real testing will happen on the provider side. So the consumer will write consumer contracts and expose these expectations to the provider by, for example, uploading it to a Pact broker. And then the provider can download them and perform live requests to a running instance of the provider application whenever they need to verify that they're in compliance. So the consumer has already provided you a contract that tells the provider what the request should look like and what they expect in return. And by separating the creation task of the test and the actual testing, we can escape the integration test hell because you're not dependent on having both applications running at the same time. So I'm going to show you a demo now. And in this demo, we can imagine that we have this whole system, but we are only going to consider application A and B, which is the application I have called Pact Consumer and Pact Provider. So let's jump into the demo. I'm just going to need the chair. Okay. So this is the first application, the Pact Consumer, but we're going to jump to the Pact Provider, and we're going to take a look at the API that I'm going to implement against today. So I have one controller here with one endpoint. It's a post to the path /version1/person. I need to send in a person object to this API, and then I just store it, give it an ID and store it, and then I return the object back with the assigned ID. And when I respond, I will send the HTTP status of 201 for created. And the person object, it looks like this. We have an integer ID. We have a string name. We have a string SSN, which is social security number. And we have a string address. So that's it. So in the consumer application, I have a normal integration test. So what I'm doing here, I'm just creating a person. I'm trying to add that person to the database or to the other application. And then I just check that the name has not changed, the social security number has not changed, and that the ID has actually been set. So I'm going to unignore this. I'm going to run this integration test. And this failed. And of course it fails because the other application is not running, so this integration test is useless. So I need to start the other application. And I can rerun the integration test. And everything is okay. So we know that everything is working. I'm not saying that integration tests are completely useless. You do need them at some point, but not during development. So for me as a developer, they're kind of useless until I'm done. So I am going to ignore this test again. And what we're going to do now, we're going to build a Pact and upload it to the Pact broker. So this here is all you need to create a simple Pact. So I'm creating a person, just like I did before. And then I'm creating the Pact right here by saying that I am the consumer called Pact Consumer. I give myself the name. And I want to have a Pact with the application called Pact Provider. Then I'm saying, giving it a description, saying that this is a create new person request. It should go to the path /version1/person. It should be a post. It should have some headers, which is just I'm saying I'm sending JSON. And I'm sending the person object as the body. And when I do that, I expect that the provider will respond with some headers, with the HTTP status for created, which is 201, and with the following body. And here I'm saying that I will have the string value, so the field name should have the string value of the person object get name. So the name has not changed, the social security number has not changed, and I expect to get back an integer type. So I expect to get an ID, but I don't care which ID. because I can't control that. And then I'm saying create this pact, and then I'm just doing what needs to be done to actually run this this pact. So on the image I showed earlier, where I send a dummy response, dummy request, get a dummy response back, this is what I'm doing. I'm just creating a dummy client, and I'm sending the object, and I expect this pact to be valid, and that will always be okay. And that's it. That's everything you need to do to create a pact. So in this demo application, I've also created a Gradle task, or I used a Gradle task called Pact Publish, which publishes this pact, the JSON structure that will be created, to the Pact broker, which I'm running locally on my computer right now. So I can just jump in here and say Gradle clean build. I will build the application. And as we can see here, the Pact Publish task was completed. It published the Pact with the name Pact Consumer to Pact Provider JSON to the Pact Broker. So now we can jump into the Pact Broker and take a look. So this is the Pact Broker. Right now it has no pacts, but if I update, we see that we have gotten one pact. So we have one application called Pact Consumer, which has a pact with Pact Provider. I can take a look at the pact. You can see all the details about the request and what I expect to get in as a response. And we can see the status of this pact, which right now is unknown. Because this is a brand new pact which has never been verified. So the status is unknown. We don't know if this pact is valid. Okay, so now we want to go to the provider application and we want to verify this pact. So right now we can see here that this is all the code you need to run or to verify simple pacts. So I'm saying that I am the provider called Pact Provider. I want to get all my pacts from the Pact broker at localhost port 3000. And then I'm saying some test target. And what does this mean? Well, this is not dummy data. So right now I'm starting my application and I'm just saying that all the tests that I'm running should be targeted to this target, which is the running instance of my application. And yeah, that's it. So I can try and run this test. And it passed. We can see that I performed verifying a pact between Pact Consumer and Pact Provider, create new person request. It had the correct response code, it had the correct headers, and it had the matching body. So we now know in the Pact Provider application that we are in compliance with whatever our consumer expects. So we can now update the pact on the Pact broker and we can see that it is verified. So everything is okay. But now I want to do what I like to do. I want to code. So I want to make some changes to the provider application. So first of all, I hate abbreviations in code because it makes it hard to read, hard to understand. So this SSN, I don't like it. So I want to remove this. So I want this to be social security number. And that's it. That's the only change I want to make. So I will run the pact verification task once more just to make sure that, okay, everything is, we're still serving the same data as we used to do before. And this test fails. And why does it fail? Because the consumer expects a field called SSN. So the message here is SSN cannot be null. If we go back to the Pact broker, we can see that, okay, this pact actually fails right now. So it's wrong. Because in the response, we expect to get an SSN field. But that's no problem. I can just fix that. I can just say that whenever I serialize this object, I will serialize social security number to a field called SSN. I can rerun the pact verification. And I'm back. Now I know that I will still serve the same data as I used before. I know that my consumers are happy. And I want to take just a couple of seconds to think about what happened here. I could actually, in isolation, on my computer, offline, no internet, nothing, I was able to actually see that the other application that uses my services was not happy with the code change I made. I didn't commit, I didn't push it to a test environment, I didn't have to do anything. I could actually discover that change on my own computer while coding. And that is one of the things I love the most about this. Because I can always know, always be sure that when I commit something, my consumers will still be happy. So I want to keep making changes. So we have this stupid string address. That doesn't really make any sense because an address is not only one single string. So I'm going to make a new Java class called address. And I want to say I want to have a private string street name. And I want to have a private string zip code. It's not perfect, but at least it's better. And I will change the data type here to address. And I will run the Pact verification just to make sure that everything is OK. And this test passed. Why did this pass? Does anyone see what happens here? Did anyone understand it?
You were testing the address.
Yes, that's correct. The consumer doesn't care about the address. The consumer never did, has never used it, doesn't care. I could delete address if I wanted to, or I could change the data type, could change the name, it doesn't matter. Because the consumer is not interested in this. So it makes it possible for me to make changes to the API without having to version the API. So now I discovered something that I could a change I could make without having to create a new API version. This is also brilliant with Pact, or consumer-driven contracts. So, but to be fair, right now I'm doing something that you should never be doing this anyways. So I'm actually making changes to the API type directly. So I shouldn't do this, so I'm going to revert all my changes, go back to the original version, and I'm going to create a new API, the version 2 API. So in order to do that, we need a new person, and I want to make that change, social security number, because I hate abbreviations. And I want to get back the address. So, oops, private string street name, private string zip code, and address. Okay, and I will need a new repository or new way of storing this new object. Oops, I'm sorry. It needs to be called version 2. And we're just going to make sure that we no longer use the version 1 person. So we see that getSSN doesn't exist in this new object, so I just need to correct that mistake. And I will need a new controller, should also be called version 2. And we want to make sure that we're not using any version 1 things. Thank you. So it should be a version 2 repository, and we need to rename the path. Okay, so I have now made a version 2 of my API. So we can just run the Pact verification task to make sure that everything is okay, all my changes did not disturb anything. And it's fine. We can see that the Pact is verified, everything is okay. And now I can let my consumer migrate over from version 1 to version 2. And that should be fairly easy. We just need to rename this, to social security number Yes, I want to refactor. I want the client to know that, okay, use version 2 instead of version 1. And that's it. That should be everything we need to do. No, one more thing. I need to tell the Pact that we're going to use a new path instead of using the path of version 1. We need to use version 2. And I can go back and I can just do a new build. For those who, with very keen eyes, you can now see that the publishing task now returned with a 200 code for OK instead of created 201, which the last one was, because we just updated a pact. So if you take a look at the pact broker, we can now see that this pact has changed. So the status is now yellow or orange instead of verified. Because no provider has yet verified this task. So I can just go back and try and verify. Fine, everything is okay. I can now see that, okay, all of my consumers are now migrated over from version 1 to version 2. Okay, so I can just delete the version 1 of the API. I don't need it anymore. So by having Pact, I could actually know that it's safe now to delete an old version of the API. And I also think that's brilliant about consumer-driven contracts. Okay, I'm going to jump back to the presentation. We're just going to do a couple of more slides. Okay, what should you have learned from this demo? First of all, testing microservices is not an easy task. And neither is having a reliable user experience when you're using a continuous deployment strategy. Things happen. So you should make sure that you as a provider of APIs, you document your APIs well, and that you have API versioning if you want to make changes. You need to make sure that your consumers write or communicate their expectations to you. So in short, consumers and providers will need to communicate, talk to each other, talk to that other team. And consumer-driven contract is a great tool to use to communicate those expectations between a consumer and a provider. And we need to remember Postle's law. You need to be conservative in what you do, and you need to be liberal in what you accept from others. So in my demo, I only sent in the SSN and the name, the social security number and the name. But even though if the provider application had responded with an address, I would just disregard that. So we need to remember this when we're building connected services. And yeah, so just actively use this principle. So you're not making fragile systems. And consumer-driven contracts, it gives developers confidence. At least it does that for me. Because confidence is a lack of risk. So if you know everything there is to know about every line of code in every microservice in your system, then you would never be afraid of making any changes, because you would know that all the changes you make to that code, you would know how that would behave for the rest of the system, or how it would affect the system. But you don't know this, I'm guessing. So you need to find some way or something to help you remove the risk of applying a change to a service. And consumer-driven contract gives you information about who is using your API, which endpoints they're using, and how they are using the data you provide. So using consumer-driven contracts will actually remove a lot of the risk of updating a service, because you now have the ability to test that you still provide the same data that the consumer expects. So performing contract verification before deployment will give developers the confidence that they need to deploy their application, and to know that they're still providing the same service as they did before. So the code demo that you saw, you can find that on my GitHub. It's a short article, poorly written, I'm afraid, but with all the repository, all the code, everything you need to set up on your computer. You only need Java 8 and Docker, that's it, and you can run everything that you just saw. If you have any questions later, you can reach me on Twitter, or you can send me an email. I also do some consultancy work on this subject, so if you, your company, or your customers would be interested in implementing this, but you don't know where to or how to get started, just send me an email.